Hi viewers, welcome back to MasterJSkills. In this video, we will see what is Spring Boot and we will discover the amazing benefits or the advantages of Spring Boot that it brings to Java application development. So furthermore to this video, I'll be creating a series of Spring Boot tutorial, this being the tutorial 1. In this Spring Boot tutorial, we will see each concept of Spring Boot with a theoretical as well as a practical code examples. I will make sure at the end of this Spring Boot series of tutorial, you will be mastering your knowledge towards Spring Boot with a great extent. But please watch the video without skipping for more clear understanding and keep supporting me by subscribing to my channel. So now let's see what is Spring Boot. Spring Boot is a framework that simplifies the development of application on top of Spring Framework. It provides an effortless and speedy way to set up, configure and run application, whether they are simple, nothing but a standalone or web-based. In Spring Boot, the need for XML configuration, which is a deployment descriptor, is eliminated. So basically Spring Boot is built on top of Spring Framework, which means it has inherited all the features in the Spring Boot like dependency injection, IOC and scope. Most of the features it has inherited. So basically in industries, most of the companies are using a Spring Boot. Why? Only because of rapid application development, that is a RAD. So it has a very minimal setup, configuration and so it has reduced the lines of code in the development, whether it may be a standalone or the web-based. So it made the developers life much more easier. So and including that, it has made the application very lightweight by excluding the XML configuration files. So only the deployment descriptors itself had lots of load on the application, which is excluded by auto configuration. We will see each of these points in later session with the coding examples. So now let's switch into the what are its benefits or what are its advantages of Spring Boot. So Spring Boot tests the web applications easily with the help of different embedded servers. So Spring Boot contains by default embedded servers which are the Tomcat, Jetty and Undertow. So the default port of this server is 8080. And we can even change that port in the application.property file with the property name called a server.port, and we can mention our own port. So before to Spring Boot, we have to build the WAV file, then we have to copy and deploy into the server, external server. So this has eliminated because Spring Boot itself is given the embedded servers. So no need of this complete manual process in the Spring Boot. So Spring Boot can create the standalone Spring application that can be started using just our Java command called java-char. Spring Boot has given the amazing feature called starters in the POM to simplify the Maven configuration. This is one of my favorite feature of a Spring Boot application. So this is one of my favorite Spring Boot advantage, that is starters POM. So before to Spring Boot, there are lots of conflicts in the dependencies. So it has eliminated within starters. We will see what the starters and all in next tutorial or the latest tutorial. So just a quick understanding, starters is nothing but like it's a bundle of related dependencies. The next is there is no requirement for XML configuration that we already we have already discussed, and it provides a production ready features such as metrics, health check and external configuration. So what is these production ready features? These are actually named in the Spring Boot as actuators. So it provides a production ready features such as metrics, health check and externalized configuration. So these are basically called as an actuator, since Spring Boot. Before to Spring Boot, if we want to check the health of our application, for example, the application is healthy or it has some failure, it's completely its status with the help of some of our own logic and own REST APIs. But that is also eliminated in the Spring Boot just by including an dependency. We can enable this feature called the actuators. So this is again the one of the good feature of a Spring Boot. And the next advantage is it increases the productivity and reduces the development time. So as I already said that Spring Boot is in the industry, it is using only because of a rapid application development, as it has reduced most of the development task of developers by reducing the development time and productivity. So when the development time itself has reduced, then the productivity automatically increased. So these are the advantages of Spring Boot. So there are lots of advantages. Among them, I have taken which are more important. So let's rewind quickly in this tutorial. What we learned is only what is Spring Boot and what are its advantages. So Spring Boot is built on top of Spring Framework, and it is used because of a rapid application development, which gives a minimal setup, configuration and development, either for standalone as well as a web-based. And it has completely eliminated external files called XMLs and made application very lightweight. This is called a Spring Boot. It's a framework. So the next is advantages. So it has given us embedded servers, and it can create a standalone just by using a java-jar command, and it has given us the starters, actuators and eliminated XML configurations. And though it has given lots of these features, it has made our productivity it has increased productivity, and it has reduced the development time. So what else required, guys? What else required? So we will explore each one of these features and master our knowledge towards a Spring Boot in this particular series of tutorials. See how to download and install STS IDE, that is Spring Tool Suite. So with the help of this video, we will be creating our Spring Boot applications, and we will see all the examples, or we can explore all the Spring features, or Spring Boot features in this STS IDE. So please watch the video without skipping for clear understanding, and keep supporting me by subscribing to MasterJSkills. So now let's see how to download and install STS. So for this, just open the Chrome or any browser. So for this, just type Spring STS download. Now you have to click on the first link, which is a Spring tool. So once you click on it, if you come down, so you will have a Spring Tool 4 for Eclipse. So according to your specification, you can download your IDE. So I have a Windows 64. I'll just click on this. So just as soon as you click on this, it will start downloading a jar file, which is a Spring Tool Suite 4 jar file. So let it download. So I have this file already downloaded here. So once you get this file, just extract it. So if you can see here, it's downloaded the same file I have downloaded previously. So just extract this file. Then if you extract, if you open, you will get all of these files. So what you have to do is just open this file, or you can pin to start. So just click on this, double click on this tool. So our STS will start preparing our workspace. So you can give your workspace. So as of now, I have given on the same workspace, or you can browse accordingly. Then you just click on launch. So it's preparing a workspace for us. So I have already created this demo. project. I'll just delete it. So once it is launched, it will be like this. So it's a fresh pack. It has a fresh package explorer. So to create our Spring Boot application, you just need to create new Spring Starter project. So just click on it. So it will ask for a name, then which type of structure you are going to build, and packaging, whether jar or var, and the version, which language you are using. I'll be using Java. So group ID we have to provide, and artifact ID, then version, and you can give the description and the package. So once you are done with this, then click on next. So here you have all the available dependencies. So you can see here, these are the starter dependencies. It has made our life much easier, that we will see in the starters video. So just for now, I'll just click on this particular jar just for demo purpose. So this particular dependency is used for this is a development tool. So whenever we modify any code in the application without restarting the server, that code will be deployed under the server. So I'll just take this dependency, then just click on next and then click finish. So once you finish, it will start creating our project. So once it has done, so you can see our project structure is ready. And I have just added the dev tool in the pom.xml. So you can see here all our Java classes in the main Java folder, and all the resources related for this Java, and all the Java test cases will be under this folder. And this is the pom.xml where all our dependencies are existed. So you can see this is already added by the Spring framework itself, as it's we will cover it in this Spring starters, and I have just added this Spring Boot dev tools. So this is the one which I have added while creating the projects. So this is quite simple how we can download and install this STS into our system. So to open importantly, if you are not installed Java, then this workspace is not going to open. So make sure you install the Java in your system. So this is all about how we can download and install STS in our system. What are the difference between a Spring Framework and Spring Boot, and why exactly we have switched from Spring Framework to Spring Boot? Please watch this video without skipping for more clear understanding, and please keep supporting me by subscribing to MasterJSkills. Without making any delay, let's understand what are the difference between the Spring Framework and Spring Boot. The first point is, Spring is an open source, lightweight framework widely used to develop enterprise application. So it's a framework which is specifically used to develop an enterprise application like web-based applications, whereas Spring Boot is built on top of conventional Spring framework widely used to develop REST API. Not only REST API, we can develop a standalone as well as a web-based application using Spring. So as per the microservice architecture, it always focuses on the small tiny application which acts as a microservice, where it always exposes a REST APIs to communicate with the other microservice. So in industry, most of the companies are using Spring Boot to develop REST APIs. It is basically built on top of Spring Framework itself. So let's see the next difference. To test the Spring project, we need to set up the server explicitly. So just think that we have built our enterprise or web-based application. Once we build the WAR file, then we to test that particular WAR file, we have to deploy in some server. So this complete process will be manual. Like we have to copy that particular WAR file to deployment folder of a server. This complete is a manual process where it requires an explicit server. whereas in Spring Boot offers embedded servers such as a Tomcat, Jetty, and Undertow. So these are the some of the embedded server which Spring Boot has given us. So here no need to apply our application explicitly to the server. Once the application has started, embedded server itself will pick it up. So this is one of the difference between Spring Framework and Spring Boot. Let's see the next difference. It helps to create a loosely coupled application. So the main advantage of using Spring Framework is a loosely coupled application where using the dependency injection of a Spring Framework feature. But wherein Spring Boot, it helps to create a standalone application. But using a Spring Framework, we can't specifically create a standalone application, whereas in Spring Boot, we can create a standalone application. The next difference is the most important feature of a Spring Framework is a dependency injection, which I have already said. So mainly the Spring Framework has introduced for loose coupling that is implemented with the help of a dependency injection. Whereas in Spring Boot, the most important feature of a Spring Framework is auto configuration. So here most of the explicit or manual process is eliminated with the help of auto configuration. So this we will see in the other video how the auto configuration will work in the Spring Boot. The Spring Framework does not provide a support for an in-memory database. So it doesn't have an in-memory database feature. So in Spring Boot, it offers several plugins for working with an embedded and in-memory databases such as H2. So we will see this in memory as well in later some of the videos. So Spring Boot has a in-memory database like H2, which is embedded into the Spring Boot. So the next difference is developers manually define dependencies for the Spring project in pom.xml. So in case of required any dependencies, then they will be manually adding into the pom.xml. But wherein Spring Boot comes with a concept called a starters in pom.xml file that internally takes care of downloading the dependencies jars based on the Spring Boot requirements. For example, if I want specifically for database, if I add a starter dependency of a JPA or then it will include most of the dependent jars of that particular feature, which is nothing but a database related features. We will see starters in deep in other video. So we have to do manual process, and here we can have the starters. So starters is nothing but a bundle of jars. So if we have included only one jar, that's enough to handle most of the features available in that particular functionality. Let's see the next difference. Configurations are done in XML files. So all the deployment descriptors is called as an deployment descriptor, where a complete configuration of application will be defined under the XML file. Where in Spring Boot, XML configuration is completely eliminated as it has a auto configuration feature. So this has made a very lightweight for the application. So how this will be handled is with the help of auto configuration, which we have already saw. Next difference is to create a Spring application, the developers write a lots of code, and here in Spring Boot, it reduces the lines of code. So Spring Boot has made a developer's life much easier with the help of starters, embedded servers, and eliminating XML configurations. And it has given lots of annotations where with the help of those annotations, we can have a lot of functionality done without much effort. So these are the main differences of Spring Framework and Spring Boot. So let's revisit one by one. First is the Spring Boot is a framework and it is used for developing an enterprise application. Spring Boot is built on top of Spring Framework, which is used to develop a standalone and REST API as well as a web-based application. So the next is it requires an explicit server, whereas a Spring Boot is embedded servers. So the next difference is Spring Boot will create a loosely coupled application, whereas Spring Boot creates a standalone application. Next is the Spring Framework. Most important feature of a Spring Framework is a dependency injection, whereas most important feature of a Spring Boot is a auto configuration. The next is the Spring Framework does not have an in-memory database, whereas the Spring Boot have a in-memory database such as a H2. The next difference is the developer manually have to manage the dependencies in pom.xml, whereas the Spring Boot has given us starters, which are a bundle of dependency will be included in the pom.xml. So the next difference is configuration file, that is a deployment descriptor, is used in the Spring Framework to configure the application, whereas in Spring Boot the deployment descriptor, which is an XML file, is completely eliminated and introduced auto configuration. The last difference is the developer has to write a lots of code including a business logic to configure and manage the complete application, whereas in Spring Boot it has reduced lines of a code due to the auto configuration feature of a Spring Boot. Yeah, these are the main difference between a Spring Framework and Spring Boot, and this is a more of a short interview question as well. So you can specify these are the main differences in the interview. Hope you all got about all the points. If you want me to explain these differences with examples of using a application or using an example, then please drop in the comment box. I will explain each of these points with an example. So if you still have any doubts, please drop in the comment box. So I'll make sure to clear all your doubts. In today's video, we will see what is a Spring Initializer, why exactly the Spring Initializer is used in Spring Boot. Please watch this video without skipping for more clear understanding. And please subscribe to MasterJSkills for more such great tutorials. Without making much delay, let's see what is a Spring Initializer. Basically, the Spring Initializer is a web-based tool. So this is a web-based tool or a web-based application which acts as a tool to create our application, Spring Boot application. With the help of Spring Initializer, we can easily generate the structure of a Spring Boot project. So to create the structure of Spring Boot project, so we can use a Spring Initializer. So there are two ways. I can show you the two ways where with the help of Spring Initializer, how we can create our Spring Boot application. They have deployed here with the help of this URL we can create. So I just copied here and I'll paste it in the browser. So let me open the browser and I'll just paste the Spring Initializer URL here. So this is what the web application of a Spring Initializer. So you can see here in which project, so which project you want to create, the project on particularly on which structure build tool you want to use. There you can select. I'll select a Maven. So and which language you can select here. I'm selecting the Java, and you can select the Spring Boot version as well. So recently it is a recent version of Spring Boot also you can see here 3.1.1, and you can select respectively. And here we have to give the group ID. So I'm just typing it as the MasterJSkills, and you can give the artifact ID as well. So Spring Boot initializer demo I am giving as a artifact ID, and you can even give the package name. Actually it will take it from the group itself. You can modify as well. So this is what the This is what our configuration, and packaging also you can mention either jar or var, and which version of a Java you want to use, that also you can mention here. And you can also add the dependencies, like I have added the Spring Boot dev tool. This is specifically is used for development purpose, where if you modify any code, then it automatically deploys in the server without modifying, without redeploying it or without restarting it. You can search whichever the jar you want. I have just selected Spring Data JPA, that you can select web, Spring Web. So you can add it any of the jars if you want. You can directly add it here. Once you are done here, you can just click on create. So what it will do, it will create a file structure or a Spring Boot application structure, and it will download as a zip. I'll just extract this. Let's extract it. Here itself I'll extract. So I have just extracted it. You can see pom.xml. If we go inside src main and test, if we go here resource and Java, this is completely I have given as a Maven structure, so it has built on particularly on that. So let's import this into our Spring tool. So I'll just import that existing Maven. So to import that particular application, just click on Maven. Just type Maven and click on existing Maven projects. Click on next and browse that particular folder, and you have done it. Just click on finish. So this application is created with the help of Spring Initializer. You can see this is our Spring main class. So these all everything automatically without any effort, without coding, it has made our life easy by ready-made solution with the help of this Spring Initializer. And let's see all the dependencies whichever we have added are present or not. I have added the JPA. This is a JPA, and I have added the web. So this is a web. I have added dev tool as well. So all the dependencies are also added, okay, with the help of Spring Initializer. And you can see this is the application context file also it has created. It will create completely our Spring Boot application structure. So with the help of this tool, we can create our application. This is a one way. So when we have already Spring tool suite, then without going to a external tool, with the help of this tool itself, we can create our Spring Boot application. For that, just right click on the package explorer, click on new, and if you go here, you can see Spring Startup project. So click on that. So it internally calls this URL itself, okay. So exactly whatever the configuration we makes here is same as here. So internally it will send these value to this particular tool itself. So I am just creating help of Spring. So I have just given this, and you can specify the type of project, packaging, version, language, and group ID, and artifact ID, and description, version, and even you can create a package as well. So once you are done, just click on next, and here also you can add the dependencies. You can see here you have added the dependency over here, and you can select here. And if you want specific version, you can select here itself. So let's take the same thing, this, and you can select anything. SQL, I'll just take this. So I'll click on next, then just click on finish. So internally it will call and fetch that particular URL. So it will send those values to that particular application, and it will start creating our Spring Boot application. This is what I have created with the help of Eclipse. So this is how you can create Spring Boot application either in the Eclipse STS itself or else with the help of Spring Initializer URL. So that is particularly the web tool. So you can see this application also has created the main class and application properties and form.xml. There we have added two dependencies. I just randomly added Spring tool and JDBC. So you can see these are the folders it will create with the files. So this is how we can create a Spring Boot application. Yeah, that's very simple how we can create a Spring Boot application. In today's video, we will see what are Spring Boot starters, where exactly it is used, how it is helping in the development, and why exactly they have introduced in this Spring Boot. We will see everything about the Spring Boot starters in this video. Please make sure to watch the video till the end so that you will not miss out any topic for more clear understanding. Please subscribe to MasterJSkills. If you like any content from the MasterJSkills or if you like any tutorial, please like that video so that it will make me to shoot more of the content on Java and J2EE. So without making much delay, let's jump into the Spring Boot starters. So before starters, I just wanted to speak on a jar. In monolithic application where we used to add the jar files in the build path. So what is this particular jar? Jar is nothing but an application which has some sort of a functionality that we will be using in our application. So it's called as a dependency. So our application is dependent on some other application functionality. That particular jar file or a jar library is called as a dependency. So dependent on some other application functionality is called the dependencies. Spring Boot starters are the bundle of dependencies, like a bundle of dependencies in the sense it has encapsulated a related bundle of jars into a single jar. So it's called the Spring Boot starters. So the Spring Boot starters are a dependency descriptors which contains a bundle of related dependencies. Spring Boot built-in starters make a development easier and rapid. So it makes development much easier and rapid because before we used to have spend our time in managing the dependencies and its version, downloading from somewhere else and adding into our build path into our application. Lots of issues with the versions. So that and all is resolved from the built-in starters. So when it has these all the tasks it has eliminated, then obviously it will make our development very rapid. So in the Spring Boot framework, all the starters follow a similar naming patterns, that is Spring Boot starter star. So star is nothing but which denotes a particular type of application or dependency. So let's have a case where Spring Boot already have a built-in starters, but if you want to import something from some other functionality, take an example of your own jar file, your own dependency or third-party dependencies. In that case, you are not supposed to use Spring Boot starters because it's specifically for official Spring Boot artifacts only. You have to add your own naming convention for your dependency. So we can even add a third-party dependencies, but the starters name is only for a Spring Boot official artifacts. So all these starter dependency where it will be added in our project, so in the pom.xml file. So let's have a look on pom.xml in IDE. So I have an application called EMS that you know that EMS I am exploring with this tutorial. So I have included most of the starters in this file. Actually, it will be included in the pom.xml. So it has only this pom.xml has only related dependencies for EMS application. So I don't want to disturb this pom.xml for this tutorial. So I have included most of the dependencies, starter dependencies in this pom.xml. So you can see, so the Spring Boot starter theme leaf. So this particular dependency starter is used to build a MVC web application using theme leaf view. So this is particularly used for view purpose, in the sense UI purpose. So when we are developing a web MVC, so in that case, if we want particular UI related dependencies, in that case we will go for theme leaf. So the next dependency is Spring Boot Starter Web Service. So this dependency is used for Spring Web Services. Okay. So the next is Spring Boot Starter Mail. This is completely related to Java Mail support. And next is Spring Boot Starter Data Redis. This is for Redis support. Redis related starter dependencies with Spring Boot Data Redis. So next starter is Spring Boot Starter Web. So this is particularly again for a Spring MVC, but it is used to it uses a Tomcat as a default embedded container. Even we can change this embedded Tomcat as well. So next is Spring Boot Starter Test. So this is particularly for to use to test the Spring Boot application with libraries like JUnit, Mockito and all. So next is Spring Boot Starter Security. It's for Spring Boot Security dependency. So next is Spring Boot Starter JPA. So this is for JPA with Hibernate. Next is Spring Boot Starter. So this is a core starter. So we have to include this one. It has a production ready features and auto configuration support. Most of the features it has added into the Spring Boot Starter. It has included many of the dependencies. Okay, next is Spring Boot Starter Data MongoDB. So this is for MongoDB database and Spring Data MongoDB. So the next is Spring Boot Starter Data REST. So when we want particularly data REST web service, then we can go for REST. And Spring Boot Actuators. This is a production ready features where we can monitor and manage our application. So the next dependency is Spring Boot Starter Undertow. This is a embedded server. If we want particularly, default is Tomcat. If we want particularly, we can have that particular dependencies. But next is Spring Boot Starter Jetty. So again, this is a embedded server. Next is Spring Boot Starter Logging. So for logging purpose, we will be using this starter. And the next is Spring Boot Starter Tomcat. It's an embedded server container. The next is Spring Boot Starter Log4j. So these are the starters. So let's go on top. So you can see here the parent tag. So inside parent we have a Spring Boot Starter parent. So what is the use of this particular element or this particular parent starter? So when we have a parent starter, what are the advantages we will see? Okay, so the Spring Boot starter parent is a project starter. It provides a default configuration for our application. So it provides the default configuration for our application. It is used internally by all the dependencies. All Spring Boot projects use a Spring Boot starter parent as a parent in the pom.xml file. So as we have saw here, it uses parent tag where it uses a default configuration. So let's see what are the default configurations. So it provides these all the configuration to the child projects. So for example, configurations, it maintains some configurations like Java version, source encoding and resource filtering, and also and it also controls the default plugin configurations. Like these are the properties. You can include any properties. So this is provided by the parent POM. So it is using a particular version. So when we define here version, so version conflicts also getting resolved because we are specifying the default version for all the dependencies will be 2.2.5 release. All the dependencies will be fetched from this release itself. So here no need to give a version. So I think I have given somewhere. I can show you, yeah, here. So here, if we want particular version override the default configuration, then we can include this version, or else if I remove this element, then it will be fetching this particular version. So this is an advantage. Having this conflict, we can mention the version in the parent starter itself. So this is one of the advantage. And here the plugins. So even it includes the plugin configuration as well. So this plugin and properties are dependent on the property configurations, gives a default configuration to the all the dependencies. So some application will not have this parent starter, so in that case there is some modification. So what is that? So in some cases every dependencies, okay, let's have a case where some projects uses a different versions, like it includes the theme leaf as in 3 version, whereas it may include web service features of a 2 version, and they need a different version for all the dependencies. Then in that case this will not come into the picture. In that case what we will be doing is we'll be doing a manual dependency management. In that case we have to include this dependency management. So inside dependency management we will be using dependencies. In that we will be using particular dependency. You can see here we have to mention the version, type of that particular jar or a dependency, and what is the scope. Everything we have to mention here in case we remove the parent starter. Indeed, in some cases we need not to inherit Spring Boot starter parent in the pom.xml file. To handle such cases, Spring Boot provides the flexibility to still use the dependency management without inheriting the Spring Boot starter parent. This is why we will be including parent starter, and without parent starter we have to include dependency management tag and include all the dependent configuration for every individual dependencies we include in our project. So this is the use of Spring Boot parent starter. Let's take one starter example, how it will be bundled, like what kind of related dependency it will include. So I will take an example of Spring Boot starter web. So the Spring Boot starter web is transitively dependent on the following. So it is dependent on Spring Boot starter, which is an basic starter, and the Spring Boot starter Tomcat, as it is a web, it needs a embedded server, and web inside that starter validation from request and response. So data should bind. So Jackson data bind it is using, and it is using Spring Web, it is using Spring MVC. So these all are bundled inside the Spring Boot web. So this is a beauty of a Spring Boot starter web. So it has basically included Tomcat, starter validation, Jackson data bind, Spring Web, and Spring MVC. So instead of including these all, we can include only one. This is a kind of an advantage. If we see what is the disadvantage of it is, we don't want a particular implementation. See, we don't want a Spring Web MVC. So in that case, simply we will be making heavier for our application. In that case, if we don't want particular jar, or if it is a conflict in the development, in that case we can exclude that particular dependency. We can exclude that dependencies like by exclusion. So in that we can exclude particular starter. So here it is excluding a Tomcat default embedded server. If you want particular server, then we can add that particular dependency. So this is how we can exclude particular dependencies from the list of or a bundle of starters from the starter Spring Boot starter. So this is how we can maintain. So this is quite simple, but we have to have a closer look in this, so you will understand much deeper. So this is all about the Spring Boot starters. So hope you all got about what are the Spring Boot starters and what are the built-in Spring Boot starters, and what is a Spring Boot starter parent, and with starter parent and without starter parent, how we can configure pom.xml, and how we can exclude a particular dependency from the starter dependency. So this is all about the Spring Boot starter. Hope you all understood what are the Spring Boot starter. The Spring Boot profiles, which are called as the application.properties. It means that application's properties. What is profile? A profile is a segregation between a different runtime environments in which the Spring application can run. For example, an application can run locally in development or test environment as well as in production. It is not easy to replicate the same hardware and software setup in all above deployment environment. So the expectation is to configure the application in such a way that it must behave correctly in all these environments. So basically the profiles are nothing but the different environments values. So we will be giving different values to specific environments. But let's take an example of locally. So locally I want to connect to the MySQL, whereas in production I want to connect to the Oracle database, or in test environment if I want to connect to the some MongoDB. So different these all have a different configurations, so different values. So for that, to segregate different environment value, the profiles has introduced. The profiles have is introduced is with the help of application.properties. So basically the application runs and takes the values for custom values from the application.properties itself, but the profiles has introduced with the help of the file name itself. So we can segregate the properties based on the environment with the help of application, with the help of properties file name itself. For example, application.properties is a default profile that we know that whenever we create any application or Spring Boot application or a Spring application, default it will create a application.properties or YAML file. Also we will use either property file or YAML files. So here I'm using application.properties. It's the same, only different file type. So accordingly we can configure. So application, so here the application.properties is a default profile, and if you want particularly for dev, we can name like this: application-dev. So this is a development environment, this is a test environment. This is how we can define different environments. Even if we have included these particular files in our application, how the application will pick, so which profile it will pick, so how it will pick, and how we can configure that, we will see in the example. Let's switch to STS. So this is a EMS application, that is employee management system. So I have created these all the different profiles. This is application.properties, application-dev means development properties, production properties, test properties. So I have just taken some random values only. This particular application is connecting to MySQL only, but the same value I have used it in all the files. You can change it accordingly, but you can observe I have just changed the port number 8081, 8082 and 8083 as a server port. Okay, and so let's run this application. So I have just enabled a dev environment. Let's open the dev one. So it is the port number is 8080 8081. So you can see here 8081 is enabled. So in application properties, we have to specify which profile, because it's a default property. With the help of this property, internally it will fetch whichever the profile. So I have given a dev. Let's make it as an prod. So I'll just make it as an prod. So let's see. You can see the Tomcat server is started on 8082. So it is running on 8082. Let's make it as a test. So it is in 8083. I'll make it as a test. I have included this dev tool, so I'm not restarting the server, but still it is deploying automatically due to this dependency only. Without restarting, it is deploying. It is started on 8083. So this is how we can enable or active our profiles. So this is a one way to configure with the these properties. Another way is this one, the configuration properties. Here I am using spring.data source. So which data source it has to pick? So profile data source, or these are the ways we can configure our data source. So you can see for dev I have used this profile and this test profile. So instead of these files, it will pick up these. Okay, but still we have to provide in this properties file itself. So it will pick from here. So let's see how I have just printed some statement. Just we will get to know how it will run. Okay. So you can see I have enabled, I think, test. Yeah, we have enabled here test. So where is the test? This is the test. You can see low cost instance I have given. So for test environment, it has picked. Either we can configure like this with the help of a class, or with the help of the properties file itself. So we can configure particularly profiles in these two ways. So hope you understood how we can activate our profiles in the Spring Boot application. Hi viewers, welcome back to MasterJSkills. In today's video, we will see what are the Spring Boot actuators. So what are the benefits of Spring Boot actuators and how we can enable the Spring Boot actuators features in our application. We will see in deep about the actuators in this video. So to have a clear understanding of a complete concept, please watch the video without skipping. And please subscribe to MasterJSkills for more such great tutorials. So without making any delay, let's get started on Spring Boot actuators. So let's take a case where without using actuators, we used to develop a particular REST API to check the health condition of our application. So let's see an example. So here I am just running this application where actuator I have disabled. I have disabled actuators. I'll just run this application. So I'm just running this application. Application is up and running on 8083. So I'll just go to browser and I'll just hit this application in browser, but I don't know what exactly is happening in the server, whether it is up or down. I'm not sure because it is just saying 404. So to check whether the application and up or not, so for this we used to write a health API just to what it will send is just it will send an text message as application is up and running. So if I click on this as well, it is saying 404 only till the context as well, it is saying 404. I'll just remove this context path as well, and if I press also, it is 404 even though our application is up and running. So let's understand what are the actuators and enable and check how what are the features when we include this actuator. So if you want to get a production ready application, we should use the Spring Boot actuator. So production ready, why it is specifically production ready? See, when the application is live, if something goes, we should go to the server and track every information. We should check the health of application. We should check the configuration. If something is gone bad or something gone wrong, we have to check the logs, and we have to take a log dump, and we have to search what exactly where exactly it's failing, and on particular what configuration as well. We have to go and check all the configurations manually backend. So instead of that, a production ready features, in the sense we can track all the information with the help of these actuators without going backend. So how that we will see with an IDE itself. So if you want to get a production ready features in an application, we should use a Spring Boot actuator. So these features are like what is the health of what I have already mentioned, health check of application, matrix of application, what are the configuration of application, what are the beans used in the application, complete information about the application will be provided by the Spring Boot actuator. So these are the features called a production ready features. So Spring Boot actuator is a sub project of Spring Boot framework itself. It's a small project in the Spring Boot framework itself. So it includes a number of additional features that help us to monitor and manage the Spring Boot application. It contains actuator endpoints, the place where resources live. So it gives all the features to manage and monitor our application. So this is the main feature or advantage of using actuators, is it gives us some features where we can monitor and manage our application. So what are the three main features of a Spring Boot actuators are endpoint, metrics and audit. So these are the main features of actuators. So what are endpoint? Where the actuator endpoints allows us to monitor and interact with the application. So it gives some of the endpoints. With that endpoints we can interact with our application. So Spring Boot provides a number of built-in endpoints. We can also create our own endpoint as well. We can enable and disable each endpoints individually as well as all of them. Most of the application uses a HTTP, where the ID of the endpoint along with the prefix of our actuator is a map to the URL. For example, health of a health endpoint provides the basic health information of an application. The actuator by default mapped into the actuator health. So this is how it will be mapped. So endpoints, it gives a predefined REST endpoints, which will with the help of these endpoints we can manage and monitor our application. We will see most of the endpoints of actuator. So it gives a metrics. Spring Boot actuator provides a dimensional metrics by interacting with the micrometer. So it interacts with the micrometer to give our application dimensional matrices. So micrometer is integrated into the Spring Boot. So it is already integrated into the Spring Boot. It is the instrumentation library powering the delivery of application metrics from Spring. It completely gives us a timer, counter, distribution summaries, and these all it will provide in the dimension with the dimension of a data model. So it completely gives a metrics of the application. So the next feature is audit. So Spring Boot provides a flexible audit framework that pushes the events to an audit event repository. It automatically publishes the authentication events if a Spring security is executed. So audit is used when our application is supporting a Spring security. So in that case, it gives a complete audit information. So authentication events, everything it will give us. So these three are the main features of Spring Boot actuators. So Spring Boot actuator endpoint. So it has some endpoints called actuator. It provides a hypermedia based discovery page for the other endpoints. It's a discovery page, so it will list all the endpoints. If we hit this particular endpoint, then it will give all the endpoint which are enabled in our application, that it will give. So audit event, again it is gives the event information of the current application. Auto configuration, it gives what are the auto configuration, and bean, it gives all the beans. Configuration properties, dump, so everything it will give. So these are the possible endpoints you can see. These all we will see with an application. So I don't want to read it again, too much of theory here. So let's see practically. So here I am not included this actuator. So without actuator, our application, even though our application is up and running, we are not able to get what is happening in our application. So we cannot monitor our application. So let's enable our actuators. I just enabled, I'm saving, and let's run this application. So our application is up and running on 8083. Now let's see. Now let's hit same. So now let's hit same server with an actuator. Link. So if we click on this, you can see our server is up and running, and it has all these possible endpoints enabled. So I didn't include anything other than this dependency. So by default it gives actuator. So you can see the same I have it. If I again click, it will be in the same. So this one, this is a actuator which will list all the possible endpoints in the application. So again, it is giving health with a particular path, health of particular API also we can give, and I'm just clicking on this. So if you see, health of our application is up. It is up and running. Okay. So just come back and just let's see the actuator info. So it doesn't contain any information, because it's completely an basic endpoints which are enabled with the help of just adding this dependency. So how we can enable, as in the discussion we have saw, it gives complete information about a configuration, beans, these all we have to enable with the external configuration, like whether we want either we may want to have all the endpoints, or we want to include completely configuration or not. It all depends on us. So we have to configure that in the application.properties. So these are the properties I have enabled. I have to make it enabled. So let me uncomment. So I am using, so you can see endpoint which all I want to expose. So I have given star. Star means all the possible endpoints. I want all. So if you want particularly include particular endpoint, that also you can specify over here. And these are, you can leave it as of now. And so let's enable. Let's save this. So again, it has deployed into. So you can see I just enabled those, exposed all, include all the endpoints. So it has listed all possible endpoints. So you can see, as we have saw beans. these are the beans it has used. It is not only includes the beans you have configured or a custom beans, it also includes dependent also. So these are the beans only. So JPA beans which is included inside. So these all the possible beans which are included in our application. So it will list out all the beans. Okay. Let's see what are the environment it is using. You can see these are the environment property sources, that is server port 8080, as it will always show the first one which is running. Active profiles is test. So currently I am using test profile. So so it will show all the configuration and path. So complete information about this environment it will show, which version it is using. So it will show the default property as well. In that I have enabled test. So dev tools, everything it will list out complete environment detail. The current active environment details it will show over here. So just if you want, if without actuator, if you want to see what particular port, on what particular port it is running, on which environment, which is active profile, everything we have to go and check backend. But with the help of actuators we can just analyze this complete endpoint. Okay, so this is about the endpoint, and I'm just showing you. I think logger is yeah. So enabled logger, you can see everything. The logger, complete logger information it will be. As of now I didn't included any loggers. So because why it is showing is because of a dependent dependencies which is included in one of the dependency which I have included in the EMS application. So heap dump, if I click on this, the dump itself will show here. So if you click on this, it will download complete heap dump. So this is a heap dump. Thread dump, again it will if you click on this, it will download, and these are the metrics. So you can see the state of a complete metrics it will be shown. So this is about the metrics. It will give and schedule task. As of now I don't have any threads enabled in my application. So apart from these there are many things which we can even include here. So raw means it will show like this, and we can include Prometheus. There are lots of things with an actuator. These are the basic things how we can enable actuators to manage and monitor our application. So these are I have included, and these are the properties. This is quite simple, and it's completely about the basic. So what are the features of actuators we have saw, and to analyze complete all the URLs, so we have to have another session or another tutorial for this particularly. If you want to know completely deep analysis of this particular URLs on particular each one of these URLs or endpoints, then comment in the comment box, then only I'll come up with a video. So this is all about the actuators Spring Boot architecture. So if you are new to this channel, please subscribe to my channel and press the bell icon to get all the notification of my channel. So without making delay, let's jump into the understanding what is the Spring Boot architecture. As we already know that the Spring Boot relies on Spring Framework. When it relies on Spring Framework, then it follows the Spring MVC architecture itself, except a repository layer. So the repository layer itself is eliminated from the Spring Boot. How? Spring's repository classes extending a CRUD repository, so it is injected into the service itself in the Spring Boot architecture. So it is completely the same structure or the same architecture as a MVC architecture, Spring MVC architecture, except the repository. So it has some theory. So Spring Boot relies heavily on Spring framework, which means that it integrates almost all the features and models of a Spring, like a Spring MVC, Spring Core, and so on. But there is no demand for your DO IMPL classes, so it doesn't force us to write our DO IMPL completely. The repository layer, it doesn't force us to write. So instead of that, it will inject into the service layer itself. Spring Boot follows a well-defined architecture flow to streamline application development. At its core, it leverages the Spring framework's powerful features and adds a layer of a simplicity. So it has a simple MVC architecture, nothing more than that. So the architecture flow begins with an application entry point known as the Spring application class. So this class initializes the Spring Boot application. So the Spring architecture flow begins with the application's entry point known as the Spring application class. This class initializes the Spring Boot application context and set up of various configurations automatically. So all the configurations are come into the live once after application starts. So the entry point is Spring application class. So the next, Spring Boot scans the applications class part to identify a components and configurations using its auto configuration mechanism. So as we already saw in the difference between Spring framework and Spring Boot, so the main feature of Spring Boot, or it focuses mainly on auto configuration. So once the application up and running, so all the configuration automatically configured with the help of auto configuration mechanism in the Spring Boot. It significantly reduces the need for manual configuration, saving developers time and effort. So it has eliminated XML configuration, which is a deployment descriptor. Completely configuration file itself it eliminated, and it made developer task much easier with the help of auto configuration mechanism. During the application startup, the Spring Boot takes advantage of embedded servers such as Tomcat, Jetty, Undertow, etc. To facilitate easy deployment. These embedded server eliminates the need for separate server installation and provides a seamless runtime environment for the application. So again, the manual process of a server installation and deploying our application into the server, these all completely eliminated with the help of embedded server. So once the application starts up, so it will deploy into the default embedded server. If you want particular server, it has a sum of the embedded server. In that, default is Tomcat. So if you want particular embedded server, then we have to configure that. So once our application starts, it will automatically deploy into the embedded server. This is all about the Spring Boot architecture theoretically. Let's see the same layer into the in practical way in the IDE. So I have an EMS application. So you can see I am not including any server here. So you can see there is no server tab over here. So I didn't include any of the servers. So let's see in the pom.xml. So I just added the web. So inside web itself, the Tomcat is enabled. So we can just include one starter which has included a default Tomcat server. So if you want particularly other than Tomcat, like Jetty or some other server, so you have to exclude Tomcat from this starter and include that particular dependency over here. So now let's see the layers. So let's see the application class itself. So this is an entry point. This is my main entry class. So we have to include this this annotation, that is Spring Boot application. This is an entry point. So it has some other configuration as well. So this is the main class, and now let's see, this is a client once controller. So once client sends requests, then we have to have a controller. So let's see, the rest is a controller. So this is the main controller. So this is controller layer. So then after that, the service layer. This is the service layer. So you can see I am not including any service. Observe carefully, I am not including at service on interface. Okay, so I didn't include. So this is my service. So this is a service class. So I am annotating with the at service. So it will implement all the interface functionality over here. So it has included. If you see employee repository, this is an interface. This is an interface. So I didn't include any repository on top of this. Let's see this one. So you can see no repository bin. So here for employee repository, I am just extending JPA repository. So you can see in this is not an interface. I'm not implementing any particular functionalities like CRUD operation. I'm not doing, but I'm just extending a CRUD service. So JPA repository. So it internally have a CRUD repository itself. So this is a CRUD repository. So I'm just extending JPA repository. So for employee, and this is a ID and the entity. So I'm not you can observe carefully, I'm not implementing anything. I have just a class and extending JPA repository. That's it, which internally calls a CRUD repository. We can directly implement a CRUD repository as well, which includes a pagination, JPA repository and CRUD repository. I'm just including JPA repository according to EMS. So in the service, I'm just injecting or I'm auto wiring it. So you can see employee repository, I'm just auto wiring. So dependency injection in the service. So I am injecting this particular repository over here. So this is how it eliminated. So before that, here one layer will come, that is an repository. So that repository will have exactly like this interface repository, and will have all these methods, these implementation again in the repository, and repository will make complete all the querying to the DB. Everything will happen. So here I'm not querying anything in the DO. I'm not doing any logic. I'm not writing any query, but still it will execute. So how? So you can see a repository dot find all. I'm not writing in this. Do you find any find all methods? Nothing. So it is inherited from this, from JPA repository itself, JPA repository implementation. So it the implementation is over here, over there. So you can see get query. So internally it will create the query. So complete implementation is inside the CRUD repository or JPA repository itself. You can extend that particular class or implement that particular interface accordingly. So even for save also, I didn't write anything. So even for save also, I didn't write anything. But if you see again persist, internally it will do the transaction. So this is how the repository it has eliminated. Without here, no need to write any basic queries and all. So this is eliminated. It is not forcing us to implement any repository. So this is about the Spring Boot architecture. So this is how the Spring Boot architecture works. So if we have a specifically, if we want specifically querying to database, then we have to include. It's not mandatorily we should remove it, but we can include as well. So that's all about the Spring Boot architect. Spring Boot auto configuration, we will see in detail about Spring Boot auto configuration. It's a very simple concept. Make sure to watch a complete video without skipping for more clarity, and don't forget to subscribe to MasterJSkills. Without making much delay, let's start. So Spring Boot auto configuration. Spring Boot auto configuration feature automatically configures the Spring application based on the jar dependencies included in the projects. It will configure automatically according to the dependencies it included, but how, in which way it will configure, we will see later. So we can enable the auto configuration feature by using the annotation called enable auto configuration. With the help of enable auto configuration annotation, we can enable the auto configuration feature of Spring Boot, but we are not using the enable auto configuration annotation as of now because it is wrapped inside the Spring Boot application annotation. So instead of using enable auto configuration, we can directly use the application Spring Boot application annotation. If enable auto configuration only included in the Spring Boot, then why to use this particular Spring Boot application annotation? Because Spring Boot application annotation also includes at component scan, enable auto configuration, add configuration. These three are included inside the Spring Boot application. Instead of including individually component scan, enable auto configuration, add configuration, so including instead of including individual these three configuration, we can directly use the Spring Boot application annotation, and it makes the Spring Boot application as an entry point for that particular class. So we are using at the Spring Boot application annotation instead of enable auto configuration to enable the auto configuration feature of a Spring Boot. So it's that simple, but here is a statement. So here it's a statement: Spring Boot auto configuration feature automatically configures the Spring application based on the jar dependencies included in the project. But how? So when we add a Spring Boot starter data JPA, for example, when we add a Spring Boot starter JPA dependency, we see that the Spring Boot auto configures the data source and entity manager. So it will configure automatically the data source as well as the entity manager when we add the data JPA. We can also disable the auto specific configuration class. So this is how when we add a dependency, this will automatically configure related things. Okay, so related configuration, it will automatically configure when we add that at the Spring Boot application annotation. So again, there is an issue, like if we don't want to apply those configuration on particular classes or particular packages, in that case, how we can exclude? So we can exclude with the help of exclude attribute of enable auto configuration. So we can also disable the specific auto configuration classes if we do not want to be applied. We use the exclude attribute of the annotation at enable auto configuration to disable the auto configuration classes. For example, at enable auto configuration of exclude equals to data source auto configuration dot class. So this class already have a configuration, then why to include auto configuration? Or this particular class don't want auto configuration, then no need of including it. So we can exclude it with the help of exclude attribute. So this is how auto configuration works. Let's see in the IDE. So as you know that this is an EMS application we have saw in the last video. So you can see this is an entry point. You can see the class name with an at Spring Boot application annotation with the main method which runs this particular class with a Spring application class is called a entry point of this application. So when this is itself is an entry point, then all the auto configuration will start from this. So this will enable the auto configuration. So this is a entry point. Apart from this, all the dependencies which is added, once the application loaded, everything will come into live. With the help of auto configuration, it will configure all of them. So as we discussed, this exclude is there in enable auto configuration. When it is wrapped inside the Spring Boot application, then this attribute should be supported into the Spring Boot application. So here as well we can include. Simply I'll take an example of entity, some entity. I'll just make it as an address dot class. So if you don't want to include auto configuration in this particular class, then you can exclude, but actually it requires, because of some mapping is done here, so obviously it will throw an exception. So auto configuration, you can see the following clause could not be excluded because they are not auto configuration classes. So this is how we can exclude it, and this is how the auto configuration will work in the Spring Boot auto configuration. We will explore all the annotations used in a Spring Boot annotation. Before making much delay, let's get into it. Before diving into all the annotations of a Spring Boot, let's understand what is annotation. So annotation is a tag that represents the metadata that is attached with the class, interface, method or field to indicate some additional information which can be used by containers. So it is nothing but telling the container that this particular class, interface, method or field is doing some functionality in terms of particular annotation. So it tells the container, like for example, at value annotation is used to fetch a property from the file. So this is how it will tell the container. So it's nothing but a tag which represents a metadata. So now let's see what are the annotations used in a Spring Boot application. So I have listed so most of them I will be showing whichever I have used in the EMS application. So Spring Boot application is an annotation is used to mark the main class of this Spring Boot application. So it makes the application entry point, and it combines functionality of at configuration, at enable auto configuration, at component scan annotation. So the next annotation is at auto wired. This annotation is used to auto wire the dependencies by type. It can be applied to field, constructor or setter method. So this is used for dependency injection by type. We can wire by other types as well. This is by default it will auto wire by the type. So with the help of an attribute we can change the by what type you want to auto wire, by constructor, by name, by type. So we can, by default it is by type. So auto wire is for auto wiring the dependencies. So at qualifier, this at qualifier is used along with the at auto wire to specify a particular bean to be auto wired when multiple beans of the same type are available. For example, there are two classes are using the same auto wiring the same class by type by default. When the same classes are auto wiring at a time, then a conflict will arise whether the container has to auto wire by which particular class, which type of a class it has to auto wire. To resolve that conflict, at qualifier is used. So you can see this annotation is used along with auto wire to specify a particular bean to be auto wired when multiple beans of the same type are available. So when have multiple beans of the same type, then at qualifier. So inside the qualifier we can specify a particular string for that type. In that case the conflict will resolve. The next annotation, at value. So this annotation is used to inject the values from a property file or an environment variables field variables into the fields or a method parameter. So this is basically used to fetch the value from the property files. Next annotation is at configuration. At configuration is used to mark a class as a configuration class in a Spring. It is typically used in combination with at bean annotation. So this particularly it's a class level annotation, and it is used to make that particular class as a configuration. For example, if you want to have a completely database configuration inside a particular class, then we can go for a at configuration. We will say the container that this particular class is belongs to configuration of something. So other what are the something will be specified in particular field, method, or class. So it tells the container to make this particular class as configurable configuration class. So the next annotation is at bean. So at bean is exactly the same tag as a at bean tag in the XML. So it's a method level annotation. It tells the method to produce a bean to be managed by the container. So it is used with the method. So we will perform some functionality inside a method, and it will return some bean, some class. So that class we are making it as a bean. That bean will be managed by the container. So to make that particular returned class as a bean, which will be managed by the Spring container. So the bean is used. It tells the method to produce a bean instead of a class. The next annotation is at a component. So it's the same annotation which we use into the Spring framework. So at component, it is a class level annotation. It is used to mark a Java class as a bean. So this is also a bean, and at component is same only, but at bean is used with a method level. At class at component is used at the class level annotation. So it is used to mark a Java class as a bean. A Java class annotated with at component is fine during the class path. The Spring framework pick it up and configure it in the application context as a Spring bean. So the next annotation is at required. It applies to the bean setter method. It indicates that the annotated bean must be populated at configuration time with the required property, else it throws an exception. Bean initialization exception. So this is mandatory to make a particular to make that particular setter method as a setter method property as a required. So mandatory. So at required is for mandatory. If we didn't populate that particular bean in the setter method, then it will throw bean initialization exception. So the next annotation is at enable auto configuration. Auto configures the bean that is present in the class path and configures it to run the methods. It uses this annotation. The use of this annotation is reduced in Spring Boot 1.2 release because the developer provided an alternative of annotation that is at Spring Boot application. So the to enable the auto configuration, this annotation is used. So in later to the 1.2 release, so it is combined with the at Spring Boot application annotation. Let's see the next annotation at controller. So this annotation is to make a class as a controller in a Spring MVC. At service is used for service to make a class as a service layer. So annotation is specialization of a at component and is used to mark a class as a service bean. At repository is for repository. At REST controller. So this annotation is a specialized version of a at controller that is used to create a RESTful web service. It combines the functionality of at controller and response body annotation. So this is a show short interview question. So what is the difference between controller and REST controller? So how we have saw this at enable auto configuration exactly same. When we use at controller, we have to write in Spring MVC, we have to return the response body. with the help of at response body. So what this will do is it will bind the response to the client values. So but in case of REST controller, this is a combined, that at controller and at response body is combined with the at REST controller. The next annotation is at request mapping. So this annotation is used to map a HTTP request to handler method in a controller. This annotation is used to map a HTTP request to handler method in the controller. It can be applied at a class level or method level. So this is for request mapping the request. So next annotations I have combined it like get mapping, post mapping, put mapping, delete mapping. So these are specifically for mapping a particular request. Like there are REST methods, that is get, post, put, delete, these methods. To map that particular HTTP request methods, these annotations are used. This at get mapping is used for get method, at post mapping is used for post mapping, at put mapping is used for put method, at delete mapping is used for delete method. But this can be used in shortcut with the request mapping itself with an method attribute of request mapping, like at request mapping method equal to request method dot fetch. So this is equivalent to this. So these are the related to REST APIs. So the next annotation is path variable. This annotation is used to bind a method parameter to a path variable in the URI template. So when we send some value of the variable in the path, that will be mapped in the map or bind in the method parameter. So that for that path variable is used. So the next annotation is at request parameter. At request param, this annotation is used to bind a method parameter to a request parameter in the query string or a form data. So if you know some knowledge on the REST API, you will get to know there are query string in the request itself. So to bind that particular request parameter, we will be using a at request param. So the next annotation is at request body. This annotation is used to bind the request body to the method parameter in controller. So this is completely the request body. This is to bind the request body to the method parameter in controller. So the next annotation is at request attribute. It binds a method parameter to request attribute. It provides a convenient access to the request attribute from a controller method. With the help of a request attribute annotation, we can access an object that are populated on a server side. So this is basically the request attribute. It binds a parameter to the request attribute. So these are very difficult to understand with theoretically. We will see each one of these annotation with an example. So next is response body. A response body annotation is used to indicate the return value of the method should be serialized and included in the response body. So this is particularly for response body. So it will bind to the response. Next is a transactional. This annotation is used to define the scope of the database transaction on a method or a class. So this is completely related to the database transaction. So it can be a method level as well as a class level. So it indicates that this particular scope is for transaction. The next is at enable auto configuration. This we already know. Next is enable web MVC. This annotation is used to enable the Spring MVC configuration when used with when using a Spring Boot. So in case of a Spring Boot, we can enable web MVC with the help of this annotation. Next is at entity. Is used to make a class as a JPA entity. Table specify a particular or map a particular class to an table. or to specify that particular class table name. Next is to specify class. Next annotation is to specify a column. The next annotation is at id. This is for to specify primary key. The next annotation is at generated value. This is to generate automatically or serially. So to generate a primary key. Basically, it is used to generate the primary key. This is used to denote that particular as the primary key. This is used to generate the key value. Next is a transactional. This we already saw. Next is at valid. This annotation is used to enable a validation on a method parameter or a return value. So for validation, we will be using at valid. Next is at exception handler. Next annotation is at exceptional handler. This annotation is used to handle exception in a controller or advice class. So this is basically used to handle the exception handler. Next is at configuration property. This annotation is used to bind the external configuration properties to the class. So this is for external configuration to the property class. So we will be going to this annotation when we don't want to modify some properties. So it's a very rare to configure. In that case, we can go for this, or else we have to if it needs more modification or more of the value is a dynamic. In that case, we will be going for application.properties itself. So next is enable configuration properties. This annotation is used to enable the configuration properties binding. So for binding the properties, we will be using this. So next is profiles. At profile is used to specify active profiles for a beans or a configuration. This is for particularly profiles. So this I think we have already saw in previous video. Next is at qualifier. This annotation is used in conjunction with at wire. So annotation this we have already discussed. I think it is repeated. Yeah, qualifier is we already discussed. The Spring Boot JPA. So please watch the video without skipping for more clear understanding, and make sure to subscribe to MasterJSkills for more such great content. So without making much delay, let's see what is the Spring Boot JPA. Spring Boot JPA is a Java specification for managing relational data in Java application. It simplifies the process of accessing and storing data between Java objects or classes and relational databases. JPA follows a object relational mapping principle, providing a set of interfaces that makes it easy to work with a database. So JPA is a persistent API for implementing ORM. So that is object relational mapping, means mapping between objects and databases. So one of the key component of a Spring Boot JPA is the Entity Manager API. It is a runtime tool that enables a developers to perform queries and transactions on objects stored in the database. With the Entity Manager API, developer can efficiently interact with the database without worrying about the underlying implementation details. So with the Spring Boot JPA here, the Entity Manager API itself will perform the queries and the transaction on the object that we want to store into the database. Here we need not to worry about the implementation. We can just make use of a Entity Manager, Spring Boot JPA Entity Manager. We will see how we will be utilizing this Entity Manager API with the help of our application, or with in a practical example. So the Spring Boot JPA also includes the Java Persistent Query Language, that is JPQL, Java Persistent Query Language. So Hibernate includes HQL, whereas Spring Boot JPA includes JPQL, that is Java Persistent Query Language, which is a query language specifically designed for JPA. So JPQL allows the developers to write object-oriented queries to retrieve data from the database. To perform any queries on the data, so Spring JPA uses JPQL, which will be querying on objects instead of directly querying on the database. So it's a kind of a HQL. It's a convenient way to fetch the information needed for a various application requirements. So JPA is not a framework. It defines a concept that can be implemented by any framework. So basically JPA is a concept that can be implemented on any framework. For example, we will be implementing it on the Spring Boot framework or the Spring framework. So let's see the JPA architecture. So persistent, so you can see the entity manager API itself will handle all the queries. So persistence created during application startup. So once the startup is application started, persistent API will be created. From that, entity manager factory will create, and then from that entity manager will create, and then our entity, that object that persists into the database with the help of entity manager. So with the help of entity manager, entity will be created that will be persisted into the database. So here you can see with the entity manager factory, so is a entity manager factory will be created, create the persistent unit. So which is unit of work with a database that will be working with an unit of work, like one by one it will be persisted by the entity manager factory. Entity manager factory will create the persistent unit. We will see each one of them here. And entity manager will create entity transaction and query. So this entity transaction will live for a shorter time, that is resides inside the session object. So let's see each one of them. So JPA architecture contains the following. Persistent, it's a class that contains static methods to obtain an entity manager factory instance. So this is a class which will obtain a entity manager factory. Entity manager factory is a factory class of an entity manager. It creates and manages multiple instances of a entity manager. So multiple instances of entity manager will be managed by the entity manager factory. Second, next is entity manager is an interface. It controls the persistence operation on objects. It works for the query instances. So for a persistent operation, entity manager is used. So entity are a persistent objects to be stored as a record in the database. This is the entity which is a persistent object. So next is persistence unit. It defines a set of all entity classes. So it defines all the entity classes. In an application, entity manager instances manage it. The set of entity classes represent the data contained within the single data store. So persistent unit contains all the entity classes. Next is entity transaction. It has a one-to-one relationship with the entity manager. For each entity manager, operations are maintained by the entity transaction. So all the transactions are managed by the entity transaction itself. Entity manager transactions are managed by the entity transaction. Next is query. So query is an interface that is implemented by each JPA vendor to obtain relational objects that meet the criteria. So you can see the flow, the persistent class to entity manager factory class to entity manager to entity. So this is a complete flow. In between them, persistent unit, because it will fetch all the required entities and the transaction on each particular entity, and querying handled by the by the entity manager. So this is a JPA architecture. Now let's see what's the difference between JPA and Hibernate. So JPA is a Java specification that is used to access, manage and persist data between Java object and relational database. It is a standard approach for ORM. So it's a Java specification to persist the data between Java objects and database. So whereas Hibernate is a lightweight open source ORM tool, it's a standard ORM approach, whereas JPA is a specification. Whereas Hibernate is an ORM tool that is used to store a Java objects in a relational database system. It is a provider for JPA. Hibernate is a provider for JPA. It follows a common approach provided by JPA. So it's a provider for JPA. JPA is a Java specification. Next is JPA uses a platform independent query language called a JPQL, Java Persistent Query Language, whereas Hibernate uses its own query language, that is Hibernate Query Language. JPA uses an entity manager for handling the persistence of a data, whereas Hibernate uses a session for handling the persistence of a data. So here entity manager is used, whereas in session is used in Hibernate. So these are the difference between JPA and Hibernate. So now let's see how we can implement a Spring Boot JPA into Spring Boot application. So for that, Spring Boot starter Data JPA is used. The Spring Boot provides a starter dependency called a Spring Boot starter Data JPA to connect Spring Boot application with a relational database effectively. The Spring Boot starter Data JPA internally uses a Spring Boot JPA dependency itself. So we have to include this dependency. So for that we will see the JPA repository. Let's see in the application to enable Spring Boot JPA. So I have included this starter, Spring Boot starter Data JPA. Let's see how we have implemented with the repository. So you can see JPA repository in the repository. So employee repository extends JPA repository. So let's see what are the JPA repository. JPA repository is a JPA that is Java Persistent API specific extension for repository. It's a extension for a repository. It contains the full API of a CRUD repository and paging and storing repository. So it contains API for basic CRUD operation and also API for paging and sorting. So whenever application is specifically for CRUD operation or paging or sorting, then no need of including our own repository layer. So we can directly use a JPA repository for these basic operations. So for this, for example, department repository extend JPA repository department, and here is a ID. So you can see for EMS application, that is employee management system, I have used employee repository extend JPA repository, and employee we have to pass employee entity we have to include with the ID. So our ID is of type integer, that we have to specify here. So what are the methods it contains? It contains save all, to save all the entities, get by ID, flush, save and flush, delete all in batch. So these are basic methods I have shown, I have listed here. So let's see directly in the class itself. So implementation I'll be opening. So for this, you can see this is an interface, extends pagination and query by example executor. There are lots of things here. For these basic operations, no need to query anything, even on objects or else on external database. So we can just call those methods which will internally create. So you can see JPA implementation, simple query, these two are there. So let's open our service. So here I have used a find all. You can see find all. Find all is used. Let's see the implementation. So here you can see find all has a get query. So we are just calling it, nothing else we are doing. everything it will do internally. So it will create a query and fetch to the database, and internally it is using criteria builder so to create query, and that query will be applied with some criteria, and we'll be selecting and sorting, and that will be returned to the caller method. So it will send list of employees. How it is giving employee, because we have passing this entity to the JPA repository, so it will do all the operation on this particular entity and its ID. So this is how the JPA repository will work. So here here the developer task made it much easier without querying. So these are the basic operation what we can do it. So this is all about JPA repository. This is how we can implement a Spring Boot JPA. Just include if we want other class, like how we can implement address class. So address JPA, and we have to include entity, and that's all. So because why I am using JPA repository is because of a CRUD operation. What I am using is a find all, and find by ID, save, delete by ID. So these all the methods I'm using. Let's see what all the methods it has. There's this find all with sort, find by ID, list, save all, flush, save and flush, delete batch, delete all in batch, get one, find all. So find all with a different sorting and different things are there. So they have given these all are the methods the JPA repository has given, and with the help of this we can do the CRUD operation easily. So this is how we can implement a Spring Boot JPA into the Spring Boot application. And that's quite simple. Include the dependency, starter dependency, and implement. Just extend this JPA repository and include your entity, which will map to the database, and inject that particular repository into the service, and just call those methods. So no need of writing the queries in the Spring Boot starter, Spring Boot JPA. So that's all about the Spring Boot JPA. The Spring Boot exception handling. How can do the global exception handling in Spring Boot? Make sure to watch the video without skipping for more clear understanding, and please subscribe to MasterJSkills for more such great tutorials. So without making any delay, let's get started. So exception, before jumping into the Spring Boot exception handling, let's recall the our core exception handling. So what are the exceptions? Exceptions are nothing but runtime errors where there will be a problem in our application and which will stop executing our application, which will terminate execution. So to handle this particular issue, exception handling come into picture, whereas exception handling is a mechanism to handle an error. So we were using a try, catch, throw and throws clauses to handle the exception in core Java. So this is how we were handling in the exception. So whereas in Spring Boot we are handling with an annotations. So let's see how we can handle in Spring Boot. So Spring Boot provides a tool to handle an exception beyond a simple try-catch blocks. To use these tools, we apply a couple of annotation that allows us to treat exception handling as a cross-cutting concerns. Spring Boot CRUD operations REST API. So here Spring Boot provides tools to handle exceptions. So for that we can call it as a cross-cutting concerns, nothing but a common functionality. Cross-cutting concerns are nothing but a common functionalities which will be handled as a global, like it will be applicable to complete application. So this is how we can handle with the help of these tools, we can handle an exception in Spring Boot. So let's see what are those tools. It provides three tools with the help of three annotations, that is response status and exception handler and control advice. With the help of these three annotations, we can handle exception globally. Let's see what is a response status. So instead of going to this theory, we'll just look into IDE, then we'll come back to here. So more clear understanding. So I'm just switching to IDE. So I'll just open the advisor. Here is an package exception. For that, customized exception handling class. So for that, I have used, you can see here, controller advice. So controller advice acts as a controller for exception handling. So for that, I have a class where it is extending response entity exception handler. So it is extending response entity exception handler. At controller advice is an annotation which acts as a controller for handling an exception. So for that, we have to extend response entity exception handler class. So once we extend this, we have to override the handle exceptions. For this, we have to make this class as an act control advice. So this annotation makes this class as an globally handle the exception. So for that, each of the exception we have to write this exception handler class. So here you can see handle exception. I am writing this employee not found exception. This is particularly for this exception where employee is not found for particular ID. So we have to write this class like employee not found extends runtime exception. So for that, we have to write a web request. So you can see the implementation itself. So here you can see handler exception, web request and exception. So exception class is our employee not found exception class. So that I am passing. And for this, I have an exception response. I am forming some response called error code, message, date, time. These are the exception responses. So that I am returning as an entity, response entity. So for that, I am setting. So response time, a response message as an employee not found, response error as 101. 101 is nothing but employee not found in the EMS. So I'm forming a response entity object. So I'm giving it as a not found. So entity, I'm passing it back to, I'm returning it back. So for the exception handler also, we have to annotate, we have to pass the entity not found exception, which is a class. So this is how we can handle the exception globally. And apart from this, we have to even include how we can catch this exception. You can see if employee is equal to null, I am throwing this employee not found exception only, this exception. So how it will be caught? It will be caught here and handled in this without try catch block. Instead of try catch, it will be handled inside here. So whenever we want, we can just make, we can throw that exception here. I can show you here as well. I have thrown just for an example. For demo purpose, I have done. See here, either I can throw runtime exception, employee ID not found exception ID, and here I am throwing this runtime. So either this or that. So before that, I'll just make it as an. So I'll copy this, paste it over here. So before going for this, I will just comment this. So without exception handling, how the application behaves, let's see. So I'm running this application, and while I'll open Postman. So our application is up and running on 8083. So I deliberately throw an exception. Let's call this method by ID. let's call this API deliberately create throw an exception. So here 2 I am passing because 2 is not existed. So it will throw internal employee ID not found. So it will throw as internal server error. So here as well you can see, because the ID we are not handling, we are just throwing it. So when if you think on core Java, core exception handling, when it is thrown, it has to be catched. It has to catch and handle. So you can see here it is throwing an exception. It is throwing the same exception in client as well as in server. So how we can handle with an global exception handling, Spring Boot exception handling is with the controller at controller advice. So I am just, what I did, just I have uncommented this, and in the controller we have to throw this exception. I'll comment this, and so here actually when either of one places I can throw, because here I can throw that exception and create that exception in the controller itself, but made it just to understand much deeper, I have throwing it in the service as well as in the controller. So this is done. I have saved it, and let's see it's updated or not. And it's updated. So I am sending this. So you can see it is not throwing any exception. It's handled with a at controller advice. So this is how we can handle the exceptions in the Spring Boot. So let's jump into the theoretical part. So at response status, as the name suggests, at response status allows us to modify the HTTP status of our response. It can be applied in the following places: on exception class itself, along with at exception handler annotation method, along with the at controller advice annotation on classes like response body. Let's apply here. So you can see here I have applied. Instead of that, we can even include here. See here, you can see there is only one exception it's handling. So then you can send this response to the class level. Instead of that, instead of when we are handling more than one exception, then we can apply it on the method as well. So here you can see for class, this is for, so here how I have included HTTP status not found, like for method as well we can include. So the response status in combination with the server.error configuration properties allows us to manipulate almost all the fields in the Spring defined error response payload. So there are some of the configuration in the application.properties as well. So these are the errors. Server.error include messages always. So here we can include whether we have to include always or false or sometimes. So it has some values. So we can include these properties, like including error server.error configuration. So in combination with the server.error configuration properties allows us to manipulate almost all the fields in our Spring defined error response payload. So this is always I have here I am including the message always, that is error response in the server. So include binding errors and include stack trace, whatever we want to include while handling, that we can mention in the properties. So next is exception handler, which we have saw in the controller, advice controller. The at exception handler annotation gives us a lot of flexibility in terms of handling exceptions. For starters, to use it, we simply need to create a method either in the controller itself or in a at controller advice class and annotate it with the at exception handler. So you can see in the advice controller, I have used an exception handler where you can see even in the REST controller as well I have used it. So you can see here the same method I have included here as well. We can include either in the controller advice or in the REST controller itself. This is how we can handle it. So next is controller advice. So controller advice is a class allows us to apply its exception handler to more than one or all controllers in our application. If we want to selectively apply or limit the scope of a controller advice to a particular controller or a package, we can use the properties provided by the annotation. If we want this particular advice to be handled globally, then no need to apply any packages. So if we want to apply this complete controller of this particular exception, so then we can mention the package like this. If we want this particular exception or this advice to be handled on complete application, then no need to specify any properties. But if we want this advice to be used by a particular controller like employee controller or particular this package, then we can specify. We can pass a package name or a list of package names in the annotation value or a base package parameter. With this the controller advice will only handle exception for this package controller. So we can even specify packages or a class. At controller annotation advice dot class, only the controllers marked with a at advice annotation will be handled by the controller advice. So at controller with annotation advice dot class, for this only the controller marked with at advice annotation will be handled by the controller advice. So this is how at controller advice we can use it. So this is quite simple how we can handle the exceptions in the global exceptions in the Spring Boot. So this is how we can handle it, all the exceptions. So that's all about the Spring Boot exception handling. If you have any doubts, please drop in the comment box. I'll make sure to clear all your doubts. And if you like this video, please give me a thumbs up and please subscribe to MasterJSkills. I'll catch you guys in the next video. Thanks again for watching.